Hello students, last class we were seeing this page number 6 questions. We have finished up to 2 questions. We'll move to the third question. In that third, give reasons. First one, a gas fills completely the vessel in which it is kept. So, gas fills completely the vessel in which it is kept. Why? Because the molecules of gas are having large distances between them. So they do not have any particular shape. Okay, molecules of gas or gas does not have any particular shape or value. Okay, so whichever container it is being taken, so there the gas is occupying that container. That means it fills the completely the vessel in which it is kept. That means the gas, it fills completely the vessel in which it is kept. Okay. Second one, a gas exerts pressure on the walls of the container. See, a gas exerts pressure on the walls of the container. Okay. See, on the walls of the container means gas molecules are having what? They have larger distance and they are very free. They move with a very speed. They move fast and they move randomly. Hence what happens? They collide each other and they collide with the walls of the container also. That is why a gas exerts pressure on the walls of the container. Third one, a wooden table should be called a solid. Why? Because a wooden table has fixed shape, fixed value, it is rigid, it is hard, so it is called as solid. Okay. We can easily move our hand in air, but to do the same through a block of wood, we need a karate expert. Why is it so? See what happens if I can move my hand here, but I cannot do the same thing with solid or a wooden block. This is because air has a larger intramolecular spaces between them, so that I can move my hand very easy. But when it comes to a solid, or say I cannot move my hand inside this, I have to put some force, because these solid particles are not having much intermolecular spaces between them, interparticle spaces between them. Particles network spaces kadime irtave, adra air or particles network spaces are jasti irtave, so that I can move my hand. But here we cannot do that because they are not having spaces, interparticular spaces between them. They are having very less intermolecular spaces between them, but in air there is a large intermolecular spaces between them. So that is why we can move our hand through air. So liquids generally have lower density as compared to solids, but you must have observed that ice floats on water. Find out why. See, liquids generally have lower density as compared to solids, but you must have observed ice floats on water. See, ice, even though it is solid, it is having large porous or large spaces in between the particles, whereas those large spaces are such in large way that they are larger compared to the spaces between the particles of water. That means the density of ice is very less compared to water. When the density of ice is less compared to water, it floats on water. If the density is more, it sinks. Density ಹೆಚ್ಚಿದ್ರೆ ನೀರೊಳಗೆ ಮುಳುಗ್ತಾ. For example, if I take a stone, ಒಂದು ಕಲ್ಲು ತಗೊಂಡು ನೀವು ನೀರಾಗ ಹೋದ್ರೆ ಮುಳುಗ್ತದೆ. ಯಾಕ? ಕಲ್ಲಿನ ಡೆನ್ಸಿಟಿ ಏನದ? ಡೆನ್ಸಿಟಿ ಆಫ್ ಸ್ಟೋನ್ ಏನದ? That is more than water. But density of ice is not the same. It has more porous. It has more spaces with ice. Ice has more interparticle spaces. So that is why the density of ice is very less compared to the density of water. Hence, ice floats on water. You should write this because density of water is more than density of ice, or you can say density of ice is less than density of water. Hence, ice floats on water. You should remember this. Okay. So this ends questions of page number 6, and after that we'll have some questions which you have already discussed, and one questions we have not discussed of page number 9. We discussed already. Okay, let me discuss it once again if you want. Convert the following temperature to Celsius scale. 300K, just you have to minus 273, you get 27 degrees Celsius. 573K minus 273, 300 degrees Celsius. What is the physical state of water at 250 degrees Celsius? See, at 250 degrees Celsius, water is at steam state. That means gaseous state. At 100 degrees Celsius, it can exist in both states because it wanted to go to gas state at that time, and it is still in liquid state. So you can say that it exists in both states, liquid as well as gas at 100 degrees Celsius. For any substance, why does the temperature remain constant during the change of state? Because it is used for the conversion of state. Whatever the temperature you are giving, that is used for the conversion of state from solid to liquid or liquid to gas. Okay, that is why the temperature remains constant. I hope already I have discussed. Suggest a method to liquefy atmospheric gases. Liquefy atmospheric gases means what? The gas is there, I want to liquefy it. That means if liquid is there, I want to make it gas, I have to increase the temperature. To liquefy the gases, I have to reduce the temperature. Just I need to what do? Reduce the temperature and increasing the pressure. Pressure needs to be increased and temperature needs to be reduced. So method is temperature has to be reduced or decreased. Decrease the temperature and increase the pressure. Increase the pressure. You have to reduce the temperature and you have to increase the pressure. Okay. So we have already seen these questions of page number 10. Why does a desert cooler cool better on a hot dry day? How does the water kept in an earthen pot become cool during summer? We have already discussed this. Why does our palm feel cold when we put some acetone or petrol or perfume on it? So why does our palm feel cold when we put some acetone? Acetone you have not come across, I think. CH3COONA. So I will write that one. So why does our palm feel cold when we put some acetone or petrol or perfume on it? Okay, I will write the formula of acetone. This is the formula of acetone. CH3COONA. Okay. Due to evaporation, we feel the cooling effect. Whether it is perfume, what is the question? Whether it is perfume or petrol or whatever, due to cooling effect, we get there. What we get? We feel a cold effect. So evaporation causes cooling, we already know that. So due to evaporation, we might say we get a cooling effect there. So you should understand this. That question, why does our palm feel cold? So why, next question, why are we able to sip hot tea or milk faster from a saucer rather than a cup? This is very much easy, no? ನೋಡ್ರಿ ನೀವು ಟೀ ಕುಡಿತಿರ್ತೀರಿ, ನಿಮ್ಮ ಕಡೆ ಕಪ್ ಇರ್ತದ, ಬಸಿ ಇರ್ತದೆ. ವಿ ಕ್ಯಾನ್ ಸಾಸರ್ಗೆ ನಾವು ಅಂತೀವಿ ಕನ್ನಡದಾಗ ಬಸಿ ಅಂತೀವಿ. ಸೊ ಕಪ್ ಒಳಗಾದ್ರೆ ಟೀ ಕುಡಿದು ಲೇಟ್ ಆಗ್ತದೆ, ಬಸಿ ಒಳಗಾದ್ರೆ ಟೀ ಕುಡಿದು ಲಘು ಆಗ್ತದೆ. ಯಾಕೆ ಹೇಳ್ರಿ? ಬಸಿ ಒಳಗೆ ಟೀ ಲಘು ಆಗ್ತದೆ. ಇದಕ್ಕೆ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಜಾಸ್ತಿ ಇರ್ತದೆ. ನೀವು ಒಂದು ಕಪ್ ತಗೊಂಡ್ರೆ ಕಪ್ ಇರುತ್ತೆ, ಬಸಿ ಹಿಂಗಿರ್ತದೆ. ಸೊ ನೋಡ್ರಿ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಜಾಸ್ತಿ ಇದೆ, ಸಿಕ್ಕಾಪಟ್ಟೆ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಅದ. ಬಟ್ ಇಲ್ಲಿ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಇಷ್ಟ ಅದ, ಕಡಿಮೆ ಅದ. ಸರ್ಫೇಸ್ ಏರಿಯಾ ಏನದ ಕಡಿಮೆ ಅದ, ಇಲ್ಲಿ ಹೆಚ್ಚು. ಸೊ ಅದರ ಸಂಬಂಧ ಏನಾಗ್ತದೆ, ಲಘು ಟೀ ಕುಡಿದ್ರಿ ಇಲ್ಲಿ ಸ್ವಲ್ಪ ಟೈಮ್ ತಗೋತದೆ. ಸೊ ಡ್ರಿಂಕಿಂಗ್ ಟೀ ಇನ್ saucer is more faster than in cup because the surface area of saucer is more compared to the surface area of cup. You can easily say that, no? Very easy thing. So what type of cloth should we wear in summer? The first two questions I have already discussed, no need to worry about that. What type of cloth should we wear in summer? Summer ಒಳಗೆ ಯಾವ ಟೈಪ್ ಬಟ್ಟೆ ಹಾಕೋತೀವಿ ನಾವು? Cotton cloths. Okay, so why? Because the cotton cloths are good absorber of heat or sweat. They take the sweat and they keep it for that sweat for evaporation. They open it for evaporation and the sweat will go evaporated, and after that it produces cooling effect. So that is why we prefer cotton cloths in summertime. Okay, so this is regarding the complete chapter. Okay, matter in our surroundings. So I hope you all are clear with the concepts. If you have any doubts, please feel free to ask doubts in WhatsApp. It's my number is given already in group. Okay, so watch the videos and ask the doubts. So please go through this, what you have learned the concept. This is very much important. You can summarize everything here. If you understand perfectly this one, you completely go through the chapter once, and after that you read this. Okay, this is very much important. Okay, and so exercise is there, so we'll do the exercise. Okay, so rather than revision, we'll complete this exercise. Okay, so exercises. So above exercise there is one table, SI unit, quantity and symbol. Be perfect with that. Temperature is measured in Kelvin and its symbol is K. Length is measured in meter, its symbol is M. Mass is measured in kilogram, its symbol is kg. Weight is measured in Newton, its symbol is N, capital N. Volume is measured in cubic meter, its symbol is MQ. Density is measured in kilogram per cubic meter, that is kg m minus q, that is kg per meter cube. Pressure is measured in Pascal, that we can say PA. Okay, so this is what we can say about this chapter. Okay, so exercise will move to convert the following temperature to the Celsius scale. See 293K, 470K. Now you ಏನು ಮಾಡಬೇಕು ಹೇಳಿದ್ರೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. 293K, 470K. 293K, 470K. We have to convert them to which one? Celsius scale. 293K Celsius ಮಾಡಿದ್ರೆ ಏನಾಗ್ತದೆ ಹೇಳ್ರಿ? ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್, that is Kc equal to ಇದನ್ನ ಸೆಲ್ಸಿಯಸ್ ಮಾಡಿದ್ರೆ ಸೆಲ್ಸಿಯಸ್ ಕಡಿಮೆ ಇರ್ತದೆ. ಕಡಿಮೆ ಸೆಲ್ಸಿಯಸ್ ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ಸೆಲ್ಸಿಯಸ್ ಕಡಿಮೆ ಇರ್ತದೆ, ಕೆಲ್ವಿನ್ ಹೆಚ್ಚಿರ್ತದೆ. ಹೆಚ್ಚಿದ ಕಡಿಮೆ ಮಾಡ್ಬೇಕಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು? ಅದನ್ನ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ಬೇಕು, ಹೌದಾ? ಸೊ 293K minus 273. So temperature in degree Celsius is equal to, or Tc you can say, is 293 273 ಹೋತಂದ್ರೆ 20 degree Celsius. ಹಿಂಗ 472 ಮಾಡ್ಬೋದಲ್ಲ? Tc equal to 470 minus 273. So if you subtract, you will get 197. 473 is 200 ಆಗ್ತದೆ. So Tc is 197 degrees Celsius. So in this way we have to solve. Very easy. ಹಿಂಗಿದ್ರೆ minus 273 ಮಾಡಬೇಕು, ಕೆಲ್ವಿನ್ ಟು ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಇದ್ರೆ. ಅದ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಟು ಕೆಲ್ವಿನ್ ಇತ್ತಂದ್ರೆ ಪ್ಲಸ್ 273 ಮಾಡಬೇಕು. ಓಕೆ, ಅವನ್ನೇ ನೋಡ್ಬಿಟ್ಟು ಕನ್ವರ್ಟ್ ದ ಫಾಲೋವಿಂಗ್ ಟೆಂಪರೇಚರ್ ಟು ದ ಕೆಲ್ವಿನ್ ಸ್ಕೇಲ್. ಕೆಲ್ವಿನ್ ಸ್ಕೇಲಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡೋದಾದ್ರೆ ನೋಡ್ರಿ, 25 degree Celsius ಇದೆ. I have to convert this to Kelvin scale. So Kelvin scale ಹೆಂಗೆ ಕನ್ವರ್ಟ್ ಮಾಡೋದು ಇದನ್ನ? 25 degrees Celsius ada. How shall I convert this to Kelvin scale? Just add 273. Tk is equal to Tc plus 273. Tc in the sense degree Celsius. 25 plus 273. 298 Kelvin. Another one is there. 373 degrees Celsius. 373 degrees Celsius ada. So just you have to add this. 373 degrees Celsius in Kelvin da madಬೇಕಂದ್ರೆ again Tk is equal to Tc plus 373. Sorry, 273. So Tc ಅಂದ್ರೆ ಎಷ್ಟು ಅದ ಇಲ್ಲಿ 373 ಅದ. 373 plus 273 ಲೆಕ್ಕ ಮಾಡ್ರಿ. 336 77 14 3216 646 Kelvin. So Tk ಏನಂದ್ರೆ 646 Kelvin. Celsius ಇದ್ದದ್ದು Kelvin ದಾಗ ಮಾಡಬೇಕಂದ್ರೆ just you have to add 273. ಅದ Kelvin ದಾಗ ಇದ್ದದ್ದು Celsius ಮಾಡಬೇಕಂದ್ರೆ you have to subtract 273. I hope you all are getting my point. So this is converting the following temperature into Celsius scale. Now we'll see the third question. Okay, we'll continue with that. We'll see the third question, that is exercise number 3. Give reason for the following observations. Naphthalene balls disappear with time without leaving any solid. Naphthalene balls disappear with time without leaving any solid means naphthalene balls easily undergoes sublimation. Sublimation you know. So change of state from solid to gas. So naphthalene balls are in solid state. They easily undergo sublimation. That means they convert to gaseous state. They got converted to gaseous state very easily. So thus you can say naphthalene balls disappear with the time without leaving any solid. ಯಾವುದೇ solid ಅನ್ನು ಬಿಡಲಾರ್ದ ಇದನ್ನಾಗ್ತದೆ due to sublimation process. Because naphthalene balls undergoes sublimation very easily, hence they disappear with time without leaving any solid. Next, we can get the smell of perfume sitting several meters away. See, smell of perfume why we get is the smells of or the particles of perfume easily diffuse into the gaseous or the air gaseous state, that is air present in surroundings. So that air will bring the smell to our nostrils. So we can easily get the smell even though we are sitting away from that, because of the diffusion of the particles of perfume into the gas, and that air moves towards us. So we get the smell of perfume very easily even though we are sitting several meters away. So fourth question, arrange the following substances in increasing order of forces of attraction between the particles: water, sugar, oxygen. See here, water, sugar, oxygen. Intermolecular force of attraction or the particle force of attraction. See here, water, sugar and oxygen, interparticle force of attraction. Sugar is highest because it is solid. In solid there is strong force of attraction between the particles. Water is liquid, here it is moderate, here it is less because oxygen is gas. So how can I write? Sugar is more, so sugar comes first, then both water and oxygen. So oxygen is the lowest, after that water, after that sugar. Okay. So next, so we have to arrange in increasing order. Increasing order means we have to write reverse. Oxygen will come first because it is having lowest, and then comes water, then comes sugar. They have asked in the increasing order. So this is the increasing order. You have to write this. Okay. Next, what is the physical state of water at 25 degrees Celsius? See, 20 at 25 degrees Celsius, it is the normal to room temperature. So at 25 degrees Celsius, water is in liquid state. So 0 to 100. So water is in liquid state. So what at 0 what happens? It is both in solid and liquid. Because it is getting converted to liquid and some part is still in solid. So water exists in both states. At 0 degrees Celsius, it exists in both solid and liquid. So next is 0 degrees Celsius only, that it exists both as well as solid as well as in liquid state. 100 degrees Celsius also same. Here it happens both in liquid and gas state. Water exists in liquid state as well as in gas state. Give two reasons to justify water at room temperature is a liquid. See, water at a room temperature is liquid because at room temperature it flows. At room temperature it does not have any shape but fixed volume. That are the properties of liquids. Properties of liquids you have to write. Any two properties you write. It flows, it does not have any fixed shape but it has fixed volume. The intermolecular force of attraction is moderate. Okay, you can write like that. Any two you write. So those are the two reasons. At room temperature you have to mention that. Then an iron alma is a solid at room temperature. Again same thing. At room temperature iron alma is first one having fixed shape and fixed value. It is rigid. It is hard. There is a strong force of attraction between the particles. It cannot be compressed. So out of this you write any two reasons you write, it is enough. Okay, so for at room temperature it is a solid. So seventh question, why is ice at 273 K more effective in cooling than water at the same temperature? See, why is ice at 273 K means 0 degrees Celsius. 273 K and 0 degrees Celsius both are same. Why ice at 273 K more effective in cooling than water at the same temperature? See, if ice is there and water is there at the same temperature, okay, here cooling ice is more effective. Why? Because ice is having latent heat here. This water is having latent heat here. See, water is having the latent heat energy, latent heat of fusion. Ice is the water ಆಗ್ತದ ಅವಾಗ ಏನಾಗ್ತದೆ water ಕಡೆ latent heat of fusion energy ಇರ್ತದೆ. So it is having more heat. To reduce it, it is having more heat than ice because it is also having latent heat also, hidden heat also there in water now. But ice is not having that hidden heat. So while cooling, it takes more time in cooling water rather than ice. So that is why the ice is cooling the ice at 0 degrees Celsius or 273 K is more effective than water at the same temperature. So 8th question, what produces more severe burns, boiling water or steam? Boiling water or steam? Obviously steam, because steam comes after the boiling water. Steam is having more temperature than the boiling water, and steam also having latent heat of energy, whereas boiling water is not having the latent heat of evaporation. Okay, but steam is having that latent heat of energy with it, so it is producing more severe burns compared to boiling water. That just they have asked what produces more severe burns, boiling water or steam. We just mention steam because it is having latent heat of energy also, hence it produces more severe burns compared to boiling water. Okay, last question, name A, B, C, D, E, F in the following diagram showing change in its state. So diagram that, so ನೀವು A, B, C, D, E, F ಅದಾವ. So I will put that diagram. Okay, that is there in your book. Solid, gas, that is complete conversion is there. Solid is there and gas is there. Okay, in solid and gas, see here. So liquid is also there. liquid is also there. So you can see gas and is connected like this. Okay. So here are A. Here is, that means this is A. This is D. This is B. This is C. So one conversion is there, solid to gas directly, that is E, and gas to solid is there, that is F. Gas to solid is there, that is my F. Of course, they have written here decrease heat and increase pressure. Decrease heat and increase pressure. Decrease heat and increase pressure. Here increase heat and decrease pressure. Here at E they have done increase heat and decrease pressure. Increase heat and decrease pressure. So you have to write water A, B, C, D, E, F. So I will write this side water A, B, C, D, E, F. See what is A, B, C, D, E, F. Okay, first one A, solid to liquid conversion. Here is A, solid to liquid. What is that process is called? Conversion of change of state from solid to liquid is called what? Melting, or other words you can say A is fusion. Fusion or melting. Define fusion. The conversion of solid state to liquid state is called as fusion. Okay. Next B, liquid to gas. Liquid to gas is vaporization. So vaporization. Liquid to gas is vaporization. Okay. Next C, just the reverse, gas to liquid. So gas to liquid means what? Here gas is there, I want to condense it to water, that means condensation. So we say C is condensation. C is condensation. So D, where is D? See here D is there. From liquid to solid, water is there. From water I am making it as ice. So from water I am making it ice means what? Liquid to solid. So pressure is here, temperature is decreasing. So which we can say that liquidification or liquefaction we can say. Okay. Or you can use another word condensation for that also. And here we can use liquidification. Gas to solid. Okay, we'll write condensation, we'll find another name for that. Condensation. So E will see here. E will see now. Now fusion over, vaporization over, condensation and condensation, some liquefaction will come there. So we'll see that. Solid to gas, that is E. Direct conversion from solid to gas is sublimation. And of course, reverse process, gas to solid is solidification. Solidification, sublimation, condensation, fusion, vaporization. So one thing we have to understand, see these are the A, B, C, D, E, F. Okay. So this question is very much important. So I think this is the condensation, vaporization, fusion and solidification. Liquid to solid is solidification. Okay. See here, liquid to solid, that is liquid to solid. D is the solidification. Solidification we can say. Solidification. So this one is either you can say deposition or sublimation. Both are same. Conversion from solid to gas is also sublimation. Gas to solid is also sublimation. but gas to solid we can sometimes call it as deposition. So these are the 6 important processes of conversion of states of matter. We have to convert this is the interconversion of states of matter. A is solid to liquid, conversion of solid to liquid, fusion, then liquid to gas, vaporization, gas to liquid, condensation, liquid to solid, solidification. Here solid to gas directly without undergoing liquid state is sublimation. Same gas to solid also called sublimation, and even it called as deposition. If you write both sublimation and deposition, it is a correct answer. So this ends your chapter, that is matter in our surroundings. You have to write down the exercise and you have to send me in WhatsApp. Okay, we'll see in the next class.